All right, guys. Today we're going to continue with reaction kinetics. This is obviously something that you learned in secondary school before. It's actually simply your speed of reaction, how fast or how slow your chemical reactions is. All right. Without further ado, let's get down to it. Okay, so in a normal chemical reactions, right, you have your reactants reacting to form your products. In an earlier topic, right, we learned under energetics that tells us about enthalpy and entropy changes. All right, so later on in the equilibrium, the chapter that we did, like the first online chapter, we learned about the factors that affect the yield of the reaction. So for this particular chapter, we'll learn about the rate of reactions and the factors which will affect the rate and the mechanism by which the reactions occur. All right. So the study of both this chapter and the chapter on energetics allows us to predict whether or not the reaction goes ahead or not based on the energy and the activation energy. All right. First, we're going to look at the quantitative analysis. Quantitative, which means that we are going to need to do some calculation. All right, so our first definition of the day, the rate of reaction is defined as the change in the concentration of reactants or products per unit time. All right, so how quickly a reaction proceeds, right, actually tells, we can determine it by measuring either the reactant or the product. Okay, so the tricky thing is actually basically just deciding which reactant or which product that can be measured easily. All right, so that for us is the most important thing, right? At least for this topic. Okay, mathematically it can be expressed as your rate of change. If you learn A math, right, you will know that rate of change is the product concentration over the time, which is the rate of change. Okay, so the negative sign, right, is to account for the decreasing concentration over time. Okay, so let's look at the rate of reaction. Okay, so now we have this particular graph, right, which the concentration is plotted against time. The concentration, you can either monitor the reactant, which is decreasing, or the product, which is increasing. All right, so the steeper your gradient, right, the faster the rate of change. So you can see right off at the start, the initial rate is always going to be the steepest gradient, because then after the initial part, the concentration will be decreasing for the reactant. All right, for the product, you'll be increasing. Okay. Okay, generally, right, the rate is directly proportional to 1 over time. So for example, right, if let's say the time taken is very short, it means that your rate is very fast. But if the time taken is very long, like a large number, your rate will be very, very small, very slow. All right. So when the gradient is equal to 0, the rate is 0 and the reaction has stopped. All right. This, I think, is quite common sense. All right. So let's look at the rate equation. All right. So why do we need such a thing called a rate equation, right? So this rate equation, right, can allow us to predict how the rate will change if a concentration of a reactant is changed. So if let's say for a particular reaction, right, we write down this rate equation. If we know the order of reaction with respect to A and B, what is order of reaction? order of reaction with respect to a reactant is the power to which the concentration of that reaction is raised to in the rate equation. Okay, and also note that this order, right, we can only determine it experimentally. It cannot be deduced directly from the rate, from the, what you call that, the balanced chemical equation. Okay, so for H2 syllabus, right, we are mainly concerned with zero, first and second order reaction. Okay, K, right, K in the rate equation is your rate constant, right, is temperature dependent and also affected by the addition of catalysts. Okay, we find the units of K only is dependent on the overall reaction. Okay, the Arrhenius equation is basically for your information, not really be tested. This equation relates activation energy, temperature, and rate in the same equation. All right, so based on this equation, right, we see that if we increase the temperature, our rate constant will increase. All right, and if we add a catalyst, the EA will become smaller, right? So mathematically, we know that the K will become larger. Okay, next we look at activation energy, EA. What is it? It is actually the minimum amount of energy reactant particle must possess before the reaction can happen. All right. It is also an indication of how fast a reaction can proceed, because a high EA, right, would actually cause the reaction to proceed very slowly, because only a very small number of molecules will have the required energy, all right, to actually lead to a successful collision, which will lead, of course, to a successful reaction. Okay, so let's come to our first quick check of the day. Given that this is the rate equation for the reaction, right, which is given to you, what is the order of reaction with respect to each of the reactant? Okay, order of reaction, you do not look at the balance equation, you look at the rate equation. All right, so for HgCl2, the order is 1. For C2O4 2-, the order is 2. All right, so this is 1 and this is 2. The overall order, you just add up the two order of reaction is 1 plus 2. I think all of you will know that it's 3. Okay, so the unit of the rate constant, right, actually depends on the unit for each of the concentration. So if we're going to plug in the figures, right, rate is actually equals to mole per dm cube per second, right? This is our K. And concentration, we again have mole per dm cube. For ethane diol is also mole per dm cube, but it is squared. All right, so what we can do is we can cancel this off because it's the same on both sides. All right, and we bring this term over to the other side. So what we're left with, right, is therefore your K is equals to the units there is. Okay, mole minus 2 dm6 per second. All right, so that is the units of the rate constant. Okay, do you manage to work that out?